For 9 straight episodes, this agent only ran while I was sitting right there, watching every step. I'd type the ticket in, watch it think, and watch it answer, one at a time. Production doesn't work like that. There's no terminal at 3 in the morning, and there's no me sitting there either. A ticket just shows up on its own, and a reply has to go out on its own. So here is the question that followed me through this whole episode. Does this agent still work once I stop watching it? Welcome back. Episode 9 left this agent secure, and episode 8 left it careful about cost, so today's build earned its spot on the scorecard. We are deploying the exact same agent the scorecard already trusts, not some fresh, untested version. But before any code, there is a decision most people make by accident. Do you run the SDK yourself on infrastructure you control, or hand the whole agent to a managed runtime someone else operates? I want to make that choice on purpose, so let's walk through it first. One honesty note: same as episode 1, today's tickets are a curated replay set. The deploy shape, the code, the builds, and the latency you are about to see are all real. So here is the fork itself. Self-hosted means you run the SDK yourself on infrastructure you control. That means you own every layer we built: the eval gate, cost guard, permission hook, and memory. But you also own the pager that goes off when something breaks. Managed is the opposite choice. A runtime hosts the agent for you, so there is less to operate and a faster start. The trade-off is the control plane, the dashboard that decides how your agent runs. On the managed side, that control plane belongs to someone else, not you. Here's what surprised me: almost none of the hard work changes depending on which side you pick. Your evals still have to pass, and your cost ceiling still has to hold. Your defense against a bad ticket has to work too. I'm self-hosting for one reason: I want every guard in code I can show you. Pick the other side instead, and almost everything else here still applies to you. So what does headless actually mean? It means the agent runs with nobody watching it and no terminal open at all. Underneath that, the whole thing collapses into one pure entry point, one function. A ticket goes in and a reply along with its telemetry comes out. There's no prompt to type into and no pause for approval. Everything else is just a wrapper built around that one function. A queue consumer pulls a ticket off the line and calls it. An HTTP handler takes a web request and calls it. A managed runtime invokes it too. The function itself never changes, no matter who's calling it. That's the mental model. Get the pure function right, and where it runs becomes a deployment detail, not a rewrite. Here is the whole entry point. It calls the shipped agent on the ticket, the V7 agent from the last 2 episodes. Then it hands back the reply, plus every number a deployed agent has to report. What it cost, how long it took, whether it escalated, and whether the cost ceiling tripped. That telemetry isn't some nice to have you bolt on later. It's the whole subject of the next episode. Now, 3 lines that matter once there's no human around anymore. I'll come back to why in a second, but for now, just notice them. Don't block waiting on input, trust only the servers I declared, and keep the cost ceiling on. In the terminal, you'd never notice these 3 lines. Headless, they're the difference between an agent that runs and one that hangs there. Now here is the gotcha, and it cost me a real morning to find. I ran the exact same code that had worked in my terminal for 9 episodes, headless this time. It hung. I watched a spinner turn for a full minute. Then it came back having done nothing. There were 2 reasons, and they turned out to be the same reason. Headless means non-interactive, nobody is there to answer a question. So when an MCP tool server paused to ask something, it just waited forever with nobody to answer. And the second reason was quieter. My terminal had been handing the code its keys and config, and none of that came along headless. So the agent came up with no tools, and worse, no way to say what had gone wrong. In the terminal, you never see this failure because you are the environment it's been leaning on. The fix turned out to be those 3 lines from a minute ago. Tell the SDK never to block waiting on a prompt. Declare which servers are allowed instead of inheriting whatever is around, and pass the environment in by hand instead of hoping it comes along for free. They look like 3 boring lines, but they are most of what production ready means. Now for the 2 things that change the moment you deploy this. For 9 episodes, we obsessed over whether the answer was correct and what each ticket cost. Production adds a third thing you can't feel in a terminal, and that's latency, especially at the tail. On the replay workload, the median ticket takes about 16 seconds, and 16 seconds is fine. But the 95th percentile, the slow end, comes in at 40 seconds. And the single slowest ticket took 70 seconds, more than a full minute. 16 typical, 40 at the tail, 70 at the worst. That's the spread this agent shifts with. It happens because the hard tickets loop more and call more tools. A human waits patiently for that. A queue at 3 in the morning will not cost holds about where episode 8 left it. About 4.5 cents a ticket, a little over $1 across 25, and the cost ceiling from episode 8 is still on now doing double duty as a production rail. Because a runaway loop nobody's watching is just a bill waiting to happen. One more time, plainly, this is still the curated replay set, and the bills and timings you just saw are real. Leave public inbound is a switch I haven't flipped yet, not a rebuild. So let's recap and let's answer the question I opened with. Does this agent still work once nobody's watching it? Yes, but only because of 3 things we did. First, the shape, one pure function, ticket in, reply out, everything else just wraps around it. Second, the fork, self-hosted or managed, and I chose self-hosted, so every guard stays in code I can show you. Third, the fix for the gotcha, don't block, declare your servers, and pass your environment yourself. And underneath all 3, watch the tail, not just the average. 16 seconds typical, 40 at the edge, 70 at the worst. That's the spread this agent ships with. The cost ceiling from episode 8 is still doing its job, a rail against a bill nobody's watching. So yes, this agent survives without me, because I designed it to. Next episode is observability, because if a ticket goes wrong at 3 in the morning, I have no idea why. So we are going to trace every token, every tool call, every run, so it can be replayed and understood. See you there.